Binary tree level order traversal. Hey everyone, this is KeyStrokes. I'm a senior software engineer at one of the FAANGs, and I like to solve LeetCode problems and programming puzzles and make videos on anything and everything about computer science. And today we'll take a look at LeetCode's problem 102, which is called binary tree level order traversal, and it's a medium difficulty problem. So let's take a look at the problem statement. We are given the root of a binary tree, and we are required to return the level order traversal of its nodes values from left to right and level by level. For example, for this tree, the level order traversal will be 3 for the first level, which we see right here. Then we have 9 and 20 for the next level, which is right here. And then we have 15 and 7 for the final level. Similarly, if we only have one node in the tree, then there's only one level, and so the answer is 1. And if there is no root at all, then we get an empty array as the output. So let's see everything that you need to know to solve this problem. You need to know how to use the while loop, and then there are quite a few data structures that will help. They are queues, trees, and lists. We'll use queues to basically order the nodes that we have to process. We'll be using lists to store the result that we have to return. And because we are operating on trees, it will be helpful to know some knowledge on how to operate on a tree. Okay, so let's get into some brainstorming and try to solve this problem. So let's say if this was a binary tree given to us. For this level, the list of nodes is 1. For this level, the list of nodes is 2, 3. And then for this level, the list of nodes is 4, 5, 6. And all we are given is the root of the tree. So let's see how we can do this. So maybe we can start by creating a queue where we push this first node into our queue. I'll just label this as queue. And now we know that everything in the queue right now are the nodes of the first level only. So what if we run a loop which doesn't end until the queue is empty? So for the first iteration, we'll pull this one value out from the queue. So this comes out from the queue and we store it, let's say, in a node variable. And then we know that 1 is the node value. So we store the value in a list, and this list will be our final result. Now, as we process 1, we should add its children to the queue as well, which is 2 and 3. And after we add the children and add the value to the list, we are done with this node. Now, if we continue with the queue, we take 2, then we add the value 2 to our result, and then we add 2's children to it, which is 4 and 5. And now we don't have to work on 2 anymore. Now we pull 3. As we iterate on it, we add 3 to our list and add its children, which is only 6. And then we are done with 3 as well. And we do the same with 4. We pull 4 out, we add it to a list. It doesn't have any more children, so we are done. Now we do the same with 5 and 6, and we add it to our list. So we are getting the nodes in a level-based order, but they are just not categorized based on a level. Because ideally we want a result which is looking like 1, then we have 2, 3, then we have 4, 5, 6. So basically for each level, we need a separate array. So let's see how we can get that. We'll again start by adding the root to our queue. And then when we process this root, we'll do the same by adding the value of this root to our result. But this time, let's add it to another list within this result list. Now, after we have added the value, let's add the children of 1 to our queue, which is 2 and 3. Now, when 1 is done, if you notice, 2 and 3 are the nodes for the next level. So what if we close this list that we had going for 1 and then start a new list? Now, when we pull 2, we put its children, which is 4 and 5, and add 2 to a result, let's say in a new list, and then we are done with 2. Now we do the same with 3, and we add its children to our queue, which will be 6, and we add 3 to the list. Now once 3 is done, again we notice that 4, 5, and 6 are the nodes of the next level. So we should close this list and now continue with our queue again. Now we process 4, 5, and 6, and none of them have a children, so we know they will be just added to our list as 4, 5, and 6. So I think as you work on our queue, we should see what the length of the queue is and then work on those many elements in the queue, because they indicate the count of nodes at the level that we are working at. For example, when we were done with 3, the queue length was 3 nodes, which is 4, 5, and 6. Now let's say 4, 5, and 6 themselves had more children. Let's say 7, 8, 9, 10, 11, and 12. Then as we process 4, 5, and 6, our queue will further on have all of these nodes from 7, 8, 9, 10, 11, and 12, which is 1, 2, 3, 4, 5, 6 nodes in total. So when we would be done with working on the 6th node, we can again take a look at the number of nodes we have in our queue, which is 6, which is clearly the nodes in the next level. Okay, so let's review this idea again. We start with a root node, we add it to the queue. Now, because the queue length is 1, let's call it len as 1, we run a loop 1 times. Now, every time before starting the loop, we create a new list. Then we pull the value from our queue, which is 1 in this case. We add it to our list, and then we add the children to the queue, which is 2 and 3 in this case. Now 1 is done, and our loop is over as well. Now the length of queue is 2, so we run a loop 2 times, and before we run the loop, we create a new list again. Now we pull 2 from the queue, we add the value of the node to our list, and then its children to our queue, which is 4 and 5. Now 2 is done. We do the same with 3, which is our final iteration of the for loop. So we pull 3 here, we add 3 to our list, and add its children to our queue, which is 6, and we're done. Now our loop is finished as well, and our queue length now becomes 3. And so now we run the loop 3 times. We pull 4, and before we do that, we have to create a new list. So we add 4 to our list, 4 is done, it has no children. Then we process 5, we add 5 to our list, and 5 is no children, so this one is done. And in the third iteration of the loop, we pull 6, and 6 again has no children. We add it to our list, and this is done as well. And the loop is over, and our queue length is 0. So we're done with our iteration, and here our result contains the list of elements for each of the levels that we can see. So here's the pseudocode of the solution that we just brainstormed. So we get the root of the tree as the input to us, and then we create a result, which is a list of lists, so that we can return the list of nodes at each level. So we start by creating a new queue, and we add root to it. Then we start a while loop, which we keep running until the queue does not become empty. Now next, we get the size of the queue, and we do this because our queue right now holds elements for one specific level. So we create a new list where we'll store all of these nodes for that level, and then we run a loop from 1 until the size, which is the number of nodes that we have at that level. And then all we do is get the node from the queue, and then if the left child of the node is not null, then we add it to the queue, and then we do the same thing with the right child of our node, and then in the end, we just add the value of the node that we are working on right now. So once this for loop is over, our queue now contains nodes for the next level. And before we continue with our next while loop iteration, we add the list which holds the nodes of the current level, and we add it to a result. And after this for loop and the while loop is done, our result will hold multiple arrays where each array represents the nodes from specific levels. Okay, so I think we can jump into our IDE and code this out. But before that, if you have been liking my explanation, please don't forget to like this video and to subscribe to my channel. And please show me your support by buying me some coffee. And if you'd like, you can also have one-on-ones with me where I can help you on how to code, prepare for interviews, get consultation on project ideas and its execution, and really anything and everything about computer science. So please find the link to the form in the description and reach out to me if you'd like to have one-on-ones with me. Well, let's jump into the IDE and code this out. Okay, so here I have IntelliJ, and we have a solution class, and we have the function signature that we see on LeetCode, which is called level order. So going back to LeetCode, we can see for level order, we take tree node as an input, which is the root of the tree, and then we need to return a list of lists of integer. We're also given this tree node here, which I've created in IntelliJ right here. So let's see how the code will look like. So the first thing we'll do is create this list of integers as the response. So we can simply do output equal to new array list, and the first check that we'll add is if root is null, then we can simply return the output as there's nothing else to do. Otherwise, we can start by creating a queue which can store tree node, and let's call it queue and use linked list as our queue. Now the first thing we'll do is add the root of the tree to this queue, and now we'll start iterating on this queue until it becomes empty. So we can do while queue is not empty, we run this loop. Now in this loop, we'll get the length of the queue currently. So we can do int queue length equal to queue.size. And once we do this, we know that this queue length represents the number of nodes at a given level that are in the queue right now. So we'll start polling for it, and we'll start adding it to a new list. So let's create that new list. We'll call it current level, and let's do new array list for it. And then we'll run a for loop. So let's do for loop equal to 0 until the queue length, and we'll do loop plus plus. Now in here, we'll poll from the queue, and we'll store it in the tree node. Let's call it node and do queue.poll. So this gives us a node from the queue. Then we do if node.left is not equal to null. That is, this node has a left node, then let's add it to our queue. So we do node.left, and we do the same thing for the right child, which is node.right, and we add it to our queue as well. Now, once the children of the node are added to the queue, we can add the value of this node to current level, which is the list that we just created, and we can do add node.val. Now, once this loop is done, we have processed all the nodes for the current level and have added the nodes for the next level to the queue. So after the loop, now this list contains all the values for the current level, and we can push this onto our output. So we can do output.add current level. Now after the queue is empty, we know that all the levels have been processed because queue won't add any more nodes if there are no more children of each of the nodes. So in the end, all we need to do is to return our output, and that should be it. Here I have a main class where I've created a bunch of example use cases similar to LeetCode. So let's run this and see if this works. And yes, it says everything is a correct answer. So let's copy our solution and put it on LeetCode. So copying the method body and going to LeetCode, and here let's just paste it and run the base cases first. And we can see that the base cases were accepted. And now let's submit this to run it on the actual test cases. And yes, this was successful and our solution was accepted. Okay, that's all I had for this video. If this video was helpful, then please don't forget to like this video and to subscribe to my channel. You can follow me on Twitter and show me your support by buying me some coffee. And you can definitely reach out to me to have any one-on-ones with me. I'm working on more videos, and in the meantime, you can try to solve the problem on the screen, which you might find interesting. Thank you for joining in. I'll see you next time.